Hi everyone, my name is Annika and I'm part of the Data Science Discovery team, and in this video today we're going to be doing a question on conditional probability. So let's go ahead and get started. So this question is very similar to all of the other conditional probability questions that we've done before, except there's a significant advantage here, I think, because we are given a table that represents all of the probabilities, right? So let's go ahead and read the question. Only 1 in 1,000 women under the age of 35 who participate in routine screening have breast cancer. Okay, so here it says 75% of women with breast cancer will correctly get a positive result. So this means that 75% of women will get a correct, true positive result, right? So given that they have a positive result given that they have breast cancer, right? And then finally, 30% of women without breast cancer will get a false positive, which means they test positive but do not have cancer. So the probability of basically that you test positive but you do not have cancer is going to be 30%. So here, what we have here is this table that represents all of these different probabilities, right? And you can definitely work this out using the Bayes theorem and other sorts of the probability formulas. But here, since we're already given a table, we can just kind of look at the numbers that are provided here that basically represent these probabilities. It's the same thing. So our first question here is, what is the chance that a woman has breast cancer given she gets a positive test result, right? So this means that we're basically finding the chance that a woman has breast cancer, so the probability of cancer, given she gets a positive test result. So it's probability of cancer given positive, right? So here we're finding the probability of cancer given that you have a positive test result. And in similar to the other conditional probability questions, the B part in our formula, the probability of A given B, the B event, represents the total that we are looking at. It represents the specific subset of the population that we are looking at. So this is basically going to be our denominator in our probability questions, right? Because probability is the number of expected outcomes divided by the number of total outcomes. And here, since we're only looking at the subset of the population that got a positive result, the number of total outcomes is basically only this part of the population, however many people that is, right? So we're not actually looking at the total. We're looking at basically this column right here, where it's probability of cancer given positive. So out of all these people who had positive results, right, that's my denominator here, 3005. That's the total number of people who got these positive results, right, with a positive result. That's the subset of the population we're looking at. So out of these 3,005 people, how many got cancer, right? Well, how many actually have cancer? Well, that's 8 of them, right? So the probability of cancer given a positive result is 8 out of 3,005, right? Because we're looking at the positive result subset of the population, right, which is 3,005. So out of these 3,005 people who had a positive result, how many got cancer? Well, that's 8 of them. So it's 8 divided by 3,005. And you don't really, you can put fractions that's equivalent. So here, we're seeing what is the chance that a randomly chosen woman has breast cancer. So we're just finding the probability of just getting cancer in general out of these when looking at this population of these 10,000 people, right? So what is the chance that a randomly chosen woman has breast cancer? Well, that's going to be a bit different here because we're not dealing with a conditional probability. We're just dealing with the probability that someone has cancer, right? Well, so here we're going to be looking at the totals, right? And kind of the tricky part of this is seeing which totals you want to look at, right? There's these marginal totals here, and I can go ahead and highlight which, if you know about marginal totals in the probability table, it's basically these probabilities that are on the margins, right? That's why it's called marginal probabilities. So here, when looking at these, how many total people are we dealing with? Well, that's going to be 10,000, right? And out of those 10,000 people, how many have cancer? Well, that's just going to be 10 of them, right? So it's basically just 1 divided by 1,000. And, it kind of tells you in the question too. So that's another way that's correct, right? So here we're just looking at the total number of people. Out of these 10,000 people, 10 have cancer. So our probability is just 1 out of 1,000 or 10 out of 10,000. And that's correct. And then now we're looking at what is the probability that someone gets a positive test result. So out of all these women, how many got a positive test result? Basically, is the probability that we're looking at. And here, that's, I still want my marginal totals, right? So that's going to be probability of a positive test result. So I still am going to be looking at this total here, right? And you may notice a pattern that, when you're dealing with conditional probabilities, you want to look at a total that is, within these margins here, right? You don't want to look at the grand total. You only want to look at a total you only want to look at a part of the population that represents whatever event you're given, right? But here, since we want the probability out of all women, how many got a positive result? Well, in that case, we're looking at the grand total, right? There's no given event that we need to account for, right? We're basically just finding out of all of these women, out of all of these 10,000 women, how many got a positive result? Well, it tells you right here, right? That's 3,005. 3,005. So that's approximately 30%, and it kind of tells you in the question here, 30% of women without breast cancer will get a false positive. That also kind of relates to the question. So here it's just 3,005 out of 10,000 will get a positive result. So and that's correct. Okay, so here a woman gets a negative test result. What is the chance that she really has breast cancer, right? So we're seeing what is the probability that a woman has cancer given that she got a negative result. Well, that's going to be probability of, just looking at the statement, cancer given a negative result. Cancer given a negative result. Well, here again, this is an example of the conditional probability, right? So here we're not going to be looking at this grand total. We're going to be looking at the part of the population that got a negative result, right? Which is basically this column right here, right? So we want to look at this column. So how many out of the people who got a negative test result, right, which was 6,995, how many of those people actually have cancer? Well, that's just 2 of them, right? It tells you right there. So again, out of this 6,995 total women, right, 6,995 total women who had a negative test result, how many got cancer? Well, how many had cancer? Well, that's only 2 of them. So our total probability is just 2 out of this 6,995. So 2 divided by 6,995, and that's the correct answer. So, in these questions where you have a table, it's pretty easy to figure out the probabilities because, everything's kind of broken down for you. I think the more tricky part is how can you kind of visualize these probabilities without a table. So that's what we're going to get to later. If you have any questions about this video, please feel free to put them down in the comments below. I hope this video was helpful, and I'll see you next time. Bye.